7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia Subduction Zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape, like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia Subduction Zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while.
Okay, smarty pants, answer this one. Do you know what earthquake magnitudes actually feel like? Well, at magnitude 1, you wouldn't notice a thing. At 3, you might slosh your coffee if you're drinking. At 5, things can start to shake off shelves, and it definitely gets your heart racing. But at 7.5, that's when the ground itself rips, buildings sway, and whole streets can split. And now, scientists warn a fault we thought wasn't active anymore could unleash something that strong under a small sleepy town in Canada. Now, if you trace your finger across a map of northwestern Canada, you'll find Dawson City in the Yukon. It looks like a nice place to escape from civilization. After all, it only has about 1,600 residents. It's quiet, remote, and famous for its gold rush past. In the late 1890s, Dawson City ballooned into a boomtown almost overnight as prospectors chased gold. Today, the rush is long gone, but the town still looks the part. Wooden boardwalks and saloon-style facades give it the feel of a set straight out of a Western movie. Oh, and beneath all of that is a fracture in the Earth itself. Dawson City is located on top of what's known as the Tintina Fault. It's a massive crack in the Earth's crust that stretches for hundreds of miles toward Alaska. Until recently, scientists believed that this zone had been inactive for over 40 million years. But newer studies tell a different story. Just a quick reminder, faults are giant cracks when two slabs of Earth's crust meet. They're always trying to slide past each other, but their jagged edges catch and lock. Pressure builds for decades, continuously bending and straining the rock. Then, suddenly, the locked zone breaks, and the slabs slip into a new position in just seconds. That abrupt lurch releases all the stored energy, sending seismic waves racing outward. The ground-shaking consequence is called an earthquake. Scientists say the ground on each side of Tintina has been trying to slide past itself for ages, but it's stuck. And now, that stuck zone has built up around 20 feet of strain. That's how far the land would shift sideways if it all gave at once. That's not just a small crack. That's straight up something from a disaster movie. If all that built-up tension snaps in one go, the result could be a magnitude 7.5 earthquake. How strong is that? Well, pretty strong. So, what happens during a big quake? The shaking can last up to 30 seconds or more, which is an eternity when the walls are swaying and the floor feels like it's rolling under your feet. If you're near the fault, things can get really scary. The ground doesn't just shake, it could take a big step sideways. This can lead to some renovations. Roads might get a new zigzag pattern, and unreinforced buildings could decide to do the twist. And if it happens in a Canadian winter, let's just say it could turn a simple power outage into a survival horror adventure. Being on soft soil is like sitting on wobbly jelly. It amplifies the shaking. Solid rock is a bit more stable. However, it's still dangerous. For example, in Mexico in 2003, a 7.5 quake damaged over 43,000 homes, buckled roads, and cut power for miles. In Sulawesi in 2018, the same magnitude not only leveled buildings, but triggered a tsunami and liquefaction. The whole neighborhood was swallowed as the ground turned to quicksand. Now here's something interesting. Most people don't think of Canada as an earthquake country, but it actually gets around 5,000 quakes a year. However, they're so small that you'd never feel them. The real hotspot is the West Coast, near British Columbia. That's where you hear people whisper about the infamous Big One. It refers to a future megathrust earthquake along the Cascadia Subduction Zone, a massive fault that runs for 600 miles just offshore. Unlike Tintina's sideways slip, Cascadia works by one tectonic plate shoving under another. For centuries, the North American plate has been bent upward like a spring as the Juan de Fuca plate has been diving below. When it finally snaps, that's a magnitude 9.0, more than 30 times stronger than a 7.5. We know it can happen because it already has. The last big one struck in 1700. It was so powerful, it didn't just shake the Pacific Northwest. It launched a tsunami across the ocean that smacked Japan, where villagers recorded an orphan wave with no local quake to explain it. Only later did scientists connect the dots. Now this brings us to the fact that despite all this, the size of the fault, the quiet buildup of strain, and the potential for a magnitude 7.5 earthquake, the Tintina Fault isn't even listed on Canada's official seismic hazard map, at least for now. That means no warnings, no color-coded danger zones. And when a fault isn't on the map, nobody designs a building for it. There's no proper preparation. You don't build reinforced structures or have seismic codes, especially when people don't expect that the ground could split open. Now, to be honest, that's not someone's mistake. The fault just didn't show any signs of being active recently. And this part of Canada is really big, quiet, and doesn't have a lot of monitoring. Not until too long ago, people had thought of the Tintina as just a geological oddity, something cool for looking at the past, but not really relevant for the future. For years, the Tintina fault flew under the radar, but that changed when researchers brought high-tech gear. They uncovered subtle but clear land shifts near Dawson City. They looked like scars on the landscape and pointed to past earthquakes, including one that pushed the land nearly 3,000 feet over millions of years. Now, interestingly, newer glacial features showed no signs of disruption, which means the last major quake probably happened right before the end of the last ice age. In geologic terms, that's pretty recent. When scientists lined up those land shifts with the ages of glaciers, the picture was clear. The Tintina fault isn't retired. It's just been on a really long coffee break, and now it's itching to clock back in. That's why researchers want it officially on Canada's seismic hazard map. Dawson City deserves more than a shrug emoji when the ground decides to stretch. The experts are basically playing detective with dirt. They're scanning forests and rivers for faint scars that past earthquakes tried to hide. They're digging trenches like archaeologists with a taste for chaos, flipping through the Earth's diary one muddy page at a time. Every crack, wrinkle, and layer adds to the story of when Tintina last threw a tantrum and how loud the next one could be. It's pretty cool that satellites can literally track if one side of a valley is slowly creeping ahead of the other, like tectonic snail racing. The goal is to find out how often this fault snapped in the past, how much stress it's still holding on to today, and whether it's going to go off quietly or all at once. Finally, just because you know that plates are pushing against each other underneath, you still can't put a date on it. Long stretches of silence might mean the rocks are getting ready for something huge, or they could just be releasing stress in tiny ways that go unnoticed. Scientists can model possibilities, but no one has a countdown clock for the next rupture. The smartest mindset isn't prediction, it's preparation. You brace for the plausible, not the precise, because the Earth's schedule doesn't come with reminders. It turns out the Earth's crust is always fidgeting. It's just that our maps are a little behind on the gossip. A fault everyone thought was harmless might actually be sitting on a magnitude 7.5 size secret. But don't worry, this isn't a cue to panic. It's a cue to get smart. Better data, sturdier buildings, and a few just-in-case habits. When the ground finally decides to settle its debt, what really matters isn't whether Dawson City feels the shake. It's whether everyone's prepared enough to turn a potential disaster into just a real wild story to tell later. Hey, have you ever been in an earthquake? I have. Tell me your story in the comments. Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely, the continent of North America would look different today. or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs, and if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia Subduction Zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia Subduction Zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia Subduction Zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia Fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia Subduction Zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia Subduction Zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
The floor is lava. Haha, just kidding. But honestly,
It's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States like the Klamath and San Joaquin all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega-floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, Projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the mid-Atlantic ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking, and the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay. Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed two sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, the physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom, it speeds up, suddenly racing forward really fast, almost as fast as sound, and that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing cracked patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia Subduction Zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors. And in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for two quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see two huge ones happen close together. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the big one. The notorious Cascadia Subduction Zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia Zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia Subduction Zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia Zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia Subduction Zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia Subduction Zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. Deep inside our planet, there are 2 massive blobs of rock that have puzzled scientists for years. They sit deep inside, opposite each other. One lurks under the Pacific Ocean, the other under Africa. And they're so weird, they even make seismic waves slow down. Their actual name is Large Low-Velocity Provinces, but they're just 2 enormous, mysterious blobs of rock, bigger than continents, stranger than anything else inside the Earth, and so dense they might be leftovers from another planet. Until recently, no one knew what they were, where they came from, or why they even exist. These mysterious blobs could hold the secret to Earth's deepest forces, powerful enough to shape earthquakes, drive volcanic eruptions, and even influence the evolution of life itself. And now, we might finally learn the truth about them. These geological monsters are hidden about 1,800 miles beneath the surface. Each one is 100 times taller than Mount Everest, so vast they defy explanation. Now, at first, scientists thought these were primordial remnants from Earth's early days. Maybe something giant smashed into Earth about 4.5 billion years ago, and this impact formed both the Moon and these blobs. Scientists believe it could have been a planet named Theia, a Mars-sized planet that existed somewhere around the asteroid belt and slammed into Earth back in the day. Others believe it could be something much more familiar, old chunks of Earth's crust. Perhaps they got pushed deep into the mantle by the movement of tectonic plates. And now, a new study shows that these blobs are massive piles of oceanic crust that have been sinking into the Earth for billions of years. They could have formed from the stuff that sinks into Earth when tectonic plates collide. Over a billion years, pieces of ocean crust could have been swallowed by the mantle. Eventually, they collected into two massive regions deep inside the planet. But even though both blobs form the same way, they aren't identical. There's this place called the Pacific Ring of Fire, a giant loop of volcanoes and earthquake zones around the Pacific Ocean. Well, the Pacific blob doesn't just stop growing and changing because it's constantly being fed fresh rock from that place. Tectonic plates crash into each other, and one plate sinks beneath another, pushing old ocean crust deep into the Earth. Since this keeps happening, the Pacific blob is heavier, denser, and more active than its twin under Africa. It's like a giant hot rock factory, constantly getting new material and reshaping itself over time. The African blob is much older and quieter than the one under the Pacific. It doesn't get fresh rock pushed into it as often. That's why, over time, it has blended more with the surrounding mantle. Since it's less dense, it behaves differently. It rises higher into the Earth's mantle, stretching 340 miles closer to the surface. And that might be why Africa has so many powerful volcanoes and rift valleys today. The biggest question is, how do they keep evolving? Scientists think that huge columns of hot rock, called mantle plumes, might be pushing up from deep inside the Earth, helping to drive the movement of tectonic plates in the Pacific. If they're right, then these giant underground blobs aren't just sitting there. They're almost alive in a way. They'd be constantly changing and shaping the surface of our planet. But why do they even matter? Because these weird underground structures may be shaping Earth's surface in ways we don't fully understand yet. You see, first, they might influence Earth's magnetic field. That's because they affect how heat moves through the mantle and core. They might also hold clues about the history of plate tectonics. Studying them could help us figure out when subduction began on Earth, whether it was over 4 billion years ago or much more recently. These guys might also be secret puppet masters behind volcanic activity. There's a theory that blazing hot rock from deep inside the Earth, the same kind that creates volcanic hotspots, might be rising straight from the giant blobs in the mantle. Some of the biggest volcanoes on Earth, including those in Hawaii, Iceland, and Yellowstone, sit directly above the suspected rising plumes from these blobs. If these blobs are fueling these volcanoes, then they could be responsible for shaping Earth's continents, climate, and even mass extinctions throughout history. And well, that's horrifying. That would mean that these giant structures might burst through Earth's crust one day, unleashing catastrophic supervolcanic eruptions, and these eruptions would last for millions of years. Beneath the Earth's surface also lies monsters unlike anything else on this planet – supervolcanoes. They're so massive, so destructive, and so rare that no human has ever witnessed one erupt. A regular volcanic eruption can be terrifying. Lava spewing into the sky, ash choking the air, entire cities buried under fire and stone. But a supervolcano? Well, that's something else entirely. A supervolcano isn't just big, it's a category of its own. Their eruptions rip apart the Earth itself, creating massive craters called calderas. Some of them are over 30 miles wide. A regular volcanic eruption might spew out a few cubic miles of lava and ash. A supervolcano unleashes more than 240 cubic miles of material. That's enough to bury an entire continent in ash. An eruption like this would be newsworthy, to say the least. First, a wall of fire would blow up into the sky. Ash would block out the sun for years, dropping global temperatures. Entire countries could be buried under meters of ash, making farming impossible. Famine, extreme cold, and toxic air could wipe out entire civilizations. It wouldn't just be a local disaster, it would be global. In fact, Two of the worst mass extinctions in Earth's history, where almost all life was wiped out, might have been caused by supervolcanoes, not asteroids. The biggest and most horrifying one was at the end of the Permian period. Literally, about 90% of all marine species and 70% of land species went poof. Scientists have counted about 20 supervolcanoes on Earth today. The most famous ones are Yellowstone in the US, Toba in Indonesia, and Topau in New Zealand. Now, the last time Yellowstone erupted was roughly 2 million years ago. It released almost 590 cubic miles of material, enough to bury a city like New York. That was just one of 3 Yellowstone supereruptions. The most recent supervolcano to erupt was Topau in New Zealand. This happened about 26,500 years ago. But supervolcanoes don't just destroy, they reshape the entire planet. About 74,000 years ago, the Toba supervolcano erupted in Indonesia. Some scientists believe it triggered a volcanic winter that lasted an entire decade. There are also theories that suggest that this eruption nearly wiped out early humans. It reduced their numbers to just a few thousand survivors, although that's just speculation. Either way, we know for sure that supervolcano eruptions have changed the course of history. So, how do we prepare for them if this could happen at any moment? Well, scientists monitor volcanoes constantly, looking for warning signs. It could be stuff like rising magma, ground swelling, earthquakes beneath a volcano, changes in gas emissions, and so on. The problem is that while we can predict short-term eruptions, the long-term ones are still a mystery. Yellowstone last erupted 630,000 years ago. It's literally overdue for another eruption already. But volcanoes don't work like clocks. Just because one erupted in the past doesn't mean it will definitely go wild again, and the time between eruptions could be random. Scientists think Yellowstone could erupt again, but it might be just a small lava flow instead of a super eruption. Are we ready for a super eruption if it happens? Probably not. Scientists say we're more prepared for an asteroid strike than a supervolcano eruption. When Hunga Tonga Hunga Ha'apai erupted in 2022, it cut off communications, caused tsunamis, and filled the sky with ash. And that was only a magnitude 5 eruption. A supervolcano would be orders of magnitude worse. So, good luck sleeping at night knowing these guys will erupt again. Maybe tomorrow, maybe in 100,000 years. Nah, don't lose sleep over it.
If you had landed on Earth a really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you would have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the boring billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called boring billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the Boring Billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now, scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup, but even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning and early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars, or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe? At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lihir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future. Not an earthquake, but a mega-earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega-earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega-earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega-earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega-earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega-earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega-earthquake and a tsunami is about 80%. Over the past 1,400 years, mega-earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega-earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. Hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation, but the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the 3rd floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing. It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity. Furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing. Factories were humming, and immigrants were arriving in large numbers, but the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region. But that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers.
Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the sixth ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that sixth ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow, and imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the afar triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
One morning, millions of New Yorkers were going to work, just like so many times before, completely unaware they'd just missed an incredible bridge replacement project. A team of engineers and builders replaced the 3-mile crossing with a new structure built to last 100 years. But the real magical part is, it happened so quietly that nobody even noticed. The Tappan Zee was the longest span in New York State from the day it opened in 1955 until 2017. It wasn't close to being the longest bridge in the US, but if you look at it from above, you can understand why people made the comparison. The name Tappan Zee comes from two parts. Tappan, the name of the local Lenape group that lived in the area, and Zee, the Dutch word for sea. But the interesting part is why it was built there in the first place. It wasn't chosen for the scenery or the engineering conditions. It was selected because of a minor monetary technicality. Someone realized, if we move the bridge just a bit farther north, New York doesn't have to share a single toll dollar with New Jersey. And just like that, a line on a map decided where millions of commuters would cross the river for the next 60 years. When the bridge was finally built, it was the era of black and white movies, rebuilding, and material shortages. The designers worked with a tight budget and predicted the structure would last about 50 years. Back then, it made sense. Traffic was lighter, cars were smaller, and nobody in the 1950s was imagining 6-lane rush hours packed with SUVs, delivery trucks, and non-stop commuter traffic. But the world didn't freeze in the 50s. Suburbs expanded, highways grew, populations shifted outward. And day after day, year after year, the Tappan Zee quietly took on more than it was ever meant to handle. By its later decades, it was carrying over 140,000 vehicles a day. Replacing it wasn't like building a new playground while kids were still playing. Shutting the span down completely wasn't an option. Traffic would have overflowed onto roads that weren't ready for it. That's why engineers decided to build a new bridge right next to the old one. This is a standard, logical, and most common procedure for major crossings that cannot be closed. However, doing this for a bridge that was longer than many famous bridges in America, as long as the span of Central Park, wasn't exactly a walk in the park. So, how do you pull off the overnight bridge construction? Well, obviously not overnight. In fact, it took years, and it was insanely expensive. But to most drivers, it felt like waking up, looking out the window, and suddenly seeing a skyscraper that they somehow didn't realize was there. While drivers kept using the old bridge, crews built the new one right beside it using equipment normally only seen on massive coastal projects. One of the coolest machines used was the left coast lifter, a floating crane nearly 330 feet tall. That's about the height of a 30-story building. It lifted massive pre-built steel sections, each weighing hundreds of tons, and placed them into position with slow, careful movements. Drivers could see the crane from the road, but because their route hadn't changed much yet, most people treated it like background construction. The new bridge grew piece by piece until the first half was strong enough to carry traffic. For drivers, it felt like the bridge was gently shifting and rearranging itself under their wheels, like a giant concrete puzzle morphing into its new shape one lane at a time. It opened in small steps, planned so drivers wouldn't feel anything unusual under their wheels. Once all cars moved onto the new span, the old Tappan Zee was taken apart slowly and safely. Most of it was removed piece by piece using cranes and barges. One section had to be taken down with controlled explosives because it wasn't stable enough for manual removal. But even that was handled early in the morning with everything blocked off and secured. This entire U.S. highway bridge engineering project, the construction, the lane shifts, and the bridge's demolition and rebuild was pulled off, and yet traffic never had to be shut down for too long. But what can we say about the new one? The old Tappan Zee Bridge was replaced by the Governor Mario M. Cuomo Bridge, named after a former New York governor. The name might not roll off the tongue, which is why locals still call it Tappan Zee, but the bridge itself is an astounding upgrade. It's a true modern structure, built to fix every weakness the original struggled with. For starters, it's much broader. The old Tappan Zee never had an emergency lane, which meant even a simple breakdown could freeze traffic for miles. The new bridge finally has space on the sides for cars to pull over safely for emergency vehicles to get through without weaving between lanes. The lanes themselves have been expanded as well to handle the demanding rush hour. It also has backup support systems built into its structure, so if one part fails, the whole bridge stays safe. Another new feature that everyone likes is a shared path for bikes and pedestrians. Now people can walk or cycle across the Hudson River, something impossible on the old span. Even the lighting was modernized. Instead of old orange bulbs, the new bridge uses bright, energy-saving LEDs that can change color for holidays and events. The new system is far more practical and easier to maintain. While the original Tappan Zee was built cheaply and quickly, this new one was designed to last at least a century. It has stronger materials, better corrosion protection, and a structure designed for today's traffic loads. But it came with a cost. And it's one question that people like asking when they hear about the upgrade. How much did this actually cost? And where did all the money go? And the answer is bigger than what most people expect. The entire project cost around $4 billion, making it one of the most expensive infrastructure replacement projects in the state's history. To many drivers, that sounds unbelievable, especially since they never felt a major interruption. But the price tag makes sense once you break it down. A large chunk of the budget went straight into the part nobody sees unless they're looking from afar: the foundations. The Hudson River near that spot is wide, deep, and uneven, and full of mud that refuses to cooperate. Engineers had to drill enormous steel piles deep into the riverbed, using machines parked on floating platforms. But then there's the bill for materials used. A modern cable-stayed bridge doesn't use bargain bin steel, it uses high-grade, corrosion-resistant, storm-ready metal and concrete, built to survive decades of trucks, wind, salt, and winter. And these weren't parts you can just pick up at a hardware store. Giant sections were custom-made in factories and shipped in by barge. However, this method was what made the whole overnight bridge construction process possible. The new bridge arrived in pieces and was literally pieced together. Labor and logistics made up a huge part of the cost. Thousands of workers rotated through scorching heat, freezing cold, fog, and rain. Coordinating barges, boats, traffic, safety crews, and big cranes beside a live highway is nothing like building on an empty lot. Every phase had to line up with the next, because one mistake could have shut down the whole crossing. That kind of workforce and planning is a big part of why the price tag was so high. But given that the bridge is breathtakingly long and will last at least a century, it looks like a significant investment. Replacing the old Tappan Zee wasn't about breaking records or building the longest bridge in the US. It was about proving that a massive bridge replacement project can proceed smoothly, safely, and almost invisibly. In the modern world, rush hours can feel like a never-ending nightmare, and thousands of outdated remnants will need to be replaced eventually. But if it can be coordinated without actually making someone late for a date or work, then it's truly worth admiring and appreciating.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's eighth continent. However, Zealandia is still debated because it's too big to be a microcontinent and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So, Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago. In 1994, the Sherman family bought a small ranch in the state of Utah, 150 miles southeast of Salt Lake City. A spacious house, beautiful nature, a starry sky. One night, Terry Sherman heard a strange noise coming from the outside. He went out of the house and saw a huge wolf. He had never seen a wolf of this size. Terry chased the animal away and ran after it, but the wolf's tracks were lost. It was as if it had disappeared into thin air. This was just one of the many creepy and strange cases that occurred at Skinwalker Ranch. The land where the farm is located used to be inhabited by the Ute people. In the past, they clashed with the Navajo, who, according to legend, sent skinwalkers on them. According to locals, a skinwalker is an evil witch who can take the form of any animal or human. There are rumors that skinwalkers still wander in this area. Perhaps the Sherman family saw one of them, but it's not that important. The fact is that the appearance of the huge wolf was just the beginning. Over the next 2 years, the family reported strange flashes of light, mysterious objects in the sky, crop circles, and mysterious voices that seemed to hover overhead. But the worst thing was the damage to livestock. The Sherman family, fortunately, acted contrary to all the cliches of horror movies. In 1996, they sold the cottage to Robert Bigelow, a man who had a lot of money and was interested in buying this particular ranch. But why? Because Robert Bigelow was a fan of strange, unusual phenomena. He founded the National Institute for Discovery Science, or NIDSI, and the area where Skinwalker Ranch is located had been the center of attraction for creepy things. Since the 1950s, there have been hundreds of reports of mysterious objects in the sky in this region. And no, those are not your typical round flying saucers. People talked about different bright lights, that took the form of doorways or portals. So, Robert Bigelow and his NID sheet reported on glowing figures and animal diseases. But over the years of research, they could not provide any reliable evidence of the existence of something extraordinary. People saw all those strange phenomena, but their equipment didn't catch anything. So it all looked like a big hoax. But in 2016, something interesting happened. Skinwalker Ranch was sold to an anonymous buyer. 4 years later, the new owner did something no one had done before. Now imagine how cool it would be if all the strange phenomena were recorded not on old video cameras with poor quality, but on cool equipment with high-resolution video recording, powerful microphones, thermal imagers, and sensors. And what if you could also watch a live broadcast using this equipment? Well, that's exactly what the new rancher did. His name is Brandon Fugel, a real estate mogul from Utah. He not only bought the ranch, but also signed a contract with the History Channel to create a show, The Secret of Skinwalker Ranch. The point of this project is to apply a scientific approach to unexplained phenomena. To do this, he turned the ranch into a big reality show that's been running for 5 years. The first thing Brandon Fugel stated was that there would be no falsifications, fakes, or computer graphics. No show exploring strange phenomena can compare with this one in terms of realism and authenticity. Fugel uses thermographic imaging systems, plane transponder data receivers, magnetometers, special cameras that detect infrared radiation and convert it to images, and other complicated scientific equipment. He shares all the data with the audience and allows the most devoted fans of the show to monitor 50 cameras with microphones installed throughout the territory live at any moment. For money, of course. Membership in the Skinwalker Ranch Insiders program starts at $8 per month. During the entire existence of the show, more than 10,000 people have signed up. Participants can not only watch the ranch through cameras, but also rotate them and zoom in and out. In addition to cameras and thermal imagers, Fugel launched special lasers into the sky that reflect off any surface. If the sky is clear, the lasers go far up. If there's an object, the lasers reflect off it. In one of the episodes, they used this equipment to detect something flying and invisible. Fugel also said that he had seen strange flying objects with his own eyes. Skinwalker Ranch turned out to be a real twilight zone for him. Now one day, the camera footage showed one of the doors slam shut. Just like that, without any wind. Other terrible phenomena are connected with livestock. Animals often get hurt, and many of them simply don't survive. And there are loads of such strange, unexplained cases. Each episode of The Secret of Skinwalker Ranch is dedicated to a phenomenon and its exploration. But has expensive equipment helped to unravel any secrets or prove the existence of extraterrestrial or mystical forces? If this had been confirmed, the whole world would probably already know about it. Therefore, at the moment, it's just an interesting show for fans of mysterious phenomena. There's no direct evidence of the existence of anything unusual there. But, at the same time, there's no explanation for many creepy things. The show offers a huge scope for speculation and research. Local folklore, flying objects, strange voices, not unlike mine, and many unexplained phenomena are all in one place. If all these stories are true, why are they happening exactly in this area? There are a lot of theories, but let's look at a few of the most popular ones. The first and most obvious one. Imagine that you have a popular show that makes you money. People watch it only because it shows mysterious, inexplicable things. But what if there's an explanation? In this case, the popularity of the show will drop and you'll lose money. It's logical, but why would a real estate mogul with a fortune of several $billion deceive people? Besides, if you watch some episodes, you'll see that Fugel is truly passionate about this project. One of the most popular theories is about visitors from other planets. After all, we have glowing flying objects, bright lights in the sky, electrical interferences, and the ability to elude camera lenses. Also, some believe that an unknown object is hidden in the mountain, located next to the ranch. What if it's a spaceship that crashed there millions of years ago and was swallowed by the mountain? It may be emitting bizarre radiation that drives animals crazy and causes hallucinations in humans. A popular but a rather banal version. Let's move on. The next theory is similar to the previous one, but instead of guests from another planet, it speaks about guests from another dimension. Ooh. Meet the multiverse version. Some unknown creatures from another reality come here, explore this ranch, and leave. This theory explains why some flying objects in the sky look like portals. Those portals may cause malfunctions in electrical appliances. There's one weak point in this theory. Why do these portals appear on the lonely ranch and nowhere else? A strange choice of travel for the residents of other dimensions. Now, the most likely theory belongs to a neuroscientist who claims that all the oddities on the ranch are connected to the geophysical force of the planet. Seismic activity, geomagnetic fields, and shifts in tectonic plates can affect some parts of the human brain responsible for hallucinations. Electromagnetic forces can also affect the stable operation of electrical appliances. So, perhaps all the oddities of this place are the result of increased seismic activity. Glowing lights, giant wolves that leave no footprints, and voices in the air can be a massive hallucination. But if this is true, why doesn't anything similar happen in other places with seismic activity? This idea leads to another theory related to electromagnetic interference. This phenomenon incapacitates batteries, drones, microphones, video cameras, and other equipment. Perhaps it affects the human brain too. But what about those poor affected animals? There are still too many unanswered questions, so stay tuned. New Zealand is located in the Southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant landmasses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Ooh. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangaea. Around 200 million years ago, yeah, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals, birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the Avulsion lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the Echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scampi, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, that's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon.
There's something strange hiding 1,800 miles down that's helping keep you and me alive. I'm talking about two massive structures beneath Africa and the Pacific Ocean that might be controlling Earth's magnetic field. Our secret heroes are rocks. Special rocks, actually. They're located right at the base of Earth's mantle, and each one is wrapped in a ring of cooler rock that runs from the North Pole to the South Pole. They are extremely hot and huge, about the size of a continent, but these structures are not like secret land masses. Think of them like blankets that sort of trap the heat. And these two big guys may have been warping Earth's magnetic field for millions of years. We'll get into that, but first, let's talk about this famous invisible force around our planet. Earth's magnetic field forms huge magnetic loops, almost like there's a giant, slightly tilted bar magnet inside our planet. It's generated in Earth's outer core. So, at the very center of Earth, you have the inner core, a super dense, solid ball that's insanely hot. That heat pushes outward into the core, a layer of liquid iron. As the liquid iron heats up, it starts to move, swirling and churning. Then those motions create powerful electric currents. This is what we know as geodynamo, a process that powers Earth's magnetic field and takes an insane amount of energy. And we love this field, okay? Because it's like a shield. It protects Earth from dangerous solar wind and cosmic radiation. Without it, yes, me and you and everyone else, we couldn't live on this planet. Over time, the field changes. Its strength goes up and down, and Earth's magnetic north and south poles slowly drift. They can even flip, but that usually takes a long time, like 300,000 years or so. And the thing steering Earth's magnetic field might be those two rock structures I mentioned earlier. So the study started with one big question. How has Earth's magnetic field changed over millions and millions of years? Thankfully, scientists can tell what it looked like in the past, thanks to rocks. Yep, some minerals have this weird ability to lock in the direction and strength of the magnetic field as they cool. That creates a record that can last for hundreds of millions of years. These hidden clues in rocks have helped scientists learn a lot about Earth's magnetic field, like its age, for example. Evidence suggests it may be at least about 4.2 billion years old. That means it's been around for almost as long as the planet itself. And it also means it's much, much older than Earth's inner core. Now you might be confused, because earlier I said the core is what generates the field, and that's true today. But back then, before the inner core formed, something else may have powered the field, like magnesium oxide. The idea is that when a giant impact formed the moon, Earth got so hot that magnesium oxide likely melted and mixed deep inside the planet. Then, as Earth slowly cooled, that material could start coming back out. That process may have helped keep the magnetic field running. But over time, Earth may have used up most of that magnesium oxide. And researchers think that's why the magnetic field almost collapsed about 565 million years ago. Yeah, we were this close to becoming a lifeless planet, like Mars or Venus. Thankfully, around that time, Earth's inner core began to form, and that gave the planet a new power source. It helped restart the geodynamo and rebuild the magnetic shield we still have today. More recently, scientists decided to take another look at our field's past. This time, they went back 265 million years. They took the magnetic signatures locked in rocks and recreated Earth's ancient magnetic field using computer simulations. And they found something interesting. In some places, the top of the outer core is much hotter, and those hot zones sit right under those two strange, massive deep rock structures. We can think of them as huge blankets, somehow trapping heat underneath. It's like they don't let heat escape as easily from below. The result is that heat builds up differently under those mantle regions. Instead of a smooth, even temperature spread, you get sharp temperature contrasts in the outer core. And that's a big deal. Until now, scientists assumed the boundary between the mantle and the core, right above the liquid iron, was pretty uniform. Kind of like an oven, heating things nice and evenly. But these new findings challenge that idea. Instead of an oven, it might be more like a stovetop with uneven burners. In hotter regions, you might think the iron moves faster, right? Like the liquid would rush. But no, it's the opposite. In the hotter zones, the liquid iron seems to slow down. In some spots, it may even almost stall, like it's getting stuck in a warm, sticky area. But under the cooler parts of the mantle, it's a different story. The liquid iron can flow more energetically. Think of a big pot of thick soup on a stove that isn't heating it evenly. In some places, the soup gets really hot, while in other places, it stays cooler. Where it's extra hot near the top, the soup ends up heavy and sluggish, but in cooler spots, it can circulate more easily. So instead of one smooth swirl through the whole pot, you get uneven motion. This uneven movement deep inside Earth leaves fingerprints. As liquid iron moves, it helps run Earth's magnetic field, almost like a natural generator. Actually, a messy one. Because while some parts of Earth's magnetic field have changed dramatically over time, other features have stayed surprisingly stable for hundreds of millions of years. In other words, the mantle is quietly shaping how the core moves, and the core's motion, in turn, shapes the magnetic field we live inside every day. That changes everything. Because for a long time, scientists have treated Earth's magnetic field like a simple, steady bar magnet pointing along the planet's spin axis. I mean, it's almost like there's a giant bar magnet inside the planet, lined up with the way Earth spins. That's why a compass usually points north, no matter where you are. It's not perfect, but it's close enough most of the time. But these new results suggest deep structures in the mantle have been bending or warping the magnetic field in a long-lasting way. And that could help explain some really weird behavior on Earth. You see, every once in a while something unusual happens. The magnetic field weakens and gets messy. Instead of acting like one clear magnet with a north and south pole, it can split into several weak mini-poles. Scientists call this a multipolar state. These events have happened many times in Earth's long history, but they are rare. And the good news is that the magnetic field doesn't stay messy for long. It usually builds itself back up and becomes strong and simple again. And what they've just found out is that those huge deep rock structures inside the Earth seem to help with this recovery. They act like stabilizers, helping the magnetic field return to its normal organized shape after it weakens. This could change how we look at a lot of Earth's past. These findings might help scientists piece together how continents were arranged long ago. For example, it could help us better understand how the supercontinent Pangaea formed and later broke apart. It could also help clear up long-standing questions about ancient climate, early life, and even how some natural resources formed. But the conclusions of this study aren't 100% certain yet, and more research is still needed. We continue to have a lot to learn about these hot, massive rock structures deep inside Earth. Still, if this idea holds up, we may have a lot to be thankful for, because these rocks might be helping keep Earth's magnetic field